What makes a fighter jet advanced? The question seems simple, right? People often think of speed, or maybe how high a plane can fly. For decades, these were the metrics that mattered most. The fastest jet was the best jet. The one that could climb steepest won the dogfight. But air combat is no longer just a contest of raw power and maneuverability. The modern battlefield is a complex network of information. It is a digital space as much as it is a physical one. True advancement in the 21st century is not just about flying faster than the other guy, it is about seeing him when he cannot see you. It is about knowing his next move before he even makes it. An advanced fighter jet today is a node in a vast, interconnected system. It is a flying supercomputer. It gathers data from every direction. It processes that information in real time. Then, it presents a clear picture of the battle space to its pilot. This allows the pilot to make smarter, faster decisions than the enemy. The fight is won not by the first to pull the trigger, but by the first to understand the situation completely. The aircraft itself becomes a tool for information dominance. This is a fundamental shift in the philosophy of air power. The jet is no longer just a weapon, it is an intelligence-gathering and network-enabling platform. It also happens to carry missiles. The Lockheed Martin F-35. A Lightning II is the embodiment of this new reality. Stealth is the F-35A's first and most critical line of defense. This is not a new concept. The F-117 Nighthawk, the B-2 Spirit bomber. But the F-35A represents a maturation of that technology. It is a more durable and sustainable form of stealth. The jet's very shape is carefully engineered to deflect radar waves away from their source. The angles of the wings, the tail fins the fuselage. There are no right angles or large, flat surfaces that would reflect a strong radar signal back to an enemy receiver. The materials used in the F-35A's construction are just as important as its shape. The skin of the aircraft is made from advanced composite materials. It is coated with a special radar-absorbent material, or RAM. This coating does exactly what its name implies. Another key element of the F-35A's stealth design is its internal carriage of weapons and fuel. Older, non-stealthy fighters carry their bombs, missiles, extra fuel tanks on pylons under their wings. These external stores create a massive radar signature. The F-35A solves this problem by carrying its primary air-to-air ordnance. When the pilot is ready to fire, the bay doors snap open for a brief moment, the weapon is released, and the doors close again. This maintains the jet's stealthy profile throughout its mission, right up to the point of attack. This combination of shape, materials, and internal carriage gives the F-35A what is known as very low observability. This drastically reduces the distance at which an enemy can detect and track the F-35A. By the time an older legacy fighter even gets a hint that an F-35A is nearby, it is often too late. The F-35A has already seen it, targeted it, and likely fired a missile. The F-35A is powered by a single Pratt & Whitney F-135 engine. This is one of the most powerful fighter engines ever built. It generates over 40,000 pounds of thrust with its afterburner engaged. This immense power allows the F-35A to accelerate rapidly and achieve a top speed of Mach 1.6, or about 1,200 miles per hour. While this is not as fast as some older fighters like the F-15 Eagle, top speed is no longer the defining characteristic of a successful fighter jet. The F-35A's performance is optimized for the modern combat environment, where stealth and sensor dominance are more important than raw velocity in a straight line. The F-135 engine provides more than just thrust. It is also a massive electrical generator. It has to be. The F-35A is packed with power-hungry electronics. The advanced radar, the distributed aperture system, the cockpit displays, and the powerful mission computers all require a tremendous amount of electrical power to function. The F-135 was designed from the outset to meet these demands. It is the heart of the aircraft, providing not only the push to move it through the air, but also the energy to run its complex digital brain. This integration of power and propulsion is a key feature that sets the F-35A apart from previous generations of aircraft. One common criticism of the F-35A is its perceived lack of maneuverability compared to some older fourth-generation fighters. The F-35A, with its internal weapons and fuel, retains its performance characteristics even when fully armed. In a realistic combat configuration, the F-35A is a formidable and highly capable performer across the entire flight envelope. If stealth is the F-35A's shield, then its sensor suite is its sword. The aircraft is equipped with an array of sensors that provide the pilot with an unprecedented view of the world around them. The centerpiece is the Northrop Grumman AN APG-81, active electronically scanned array radar. Unlike older mechanically scanned radars, the APG-81 can scan huge volumes of airspace almost instantaneously. It can track a large number of targets simultaneously, in the air, on the ground. It can also perform electronic warfare functions, jamming enemy radars and jamming communications. The F-35A also features an electro-optical targeting system, or EOTS. This is a sensor mounted under the nose, housed behind a stealthy diamond-shaped window. EOTS provides passive infrared search and track capabilities, allowing the F-35A to find and target enemy aircraft without using its own radar. The most revolutionary sensor system on the F-35A is the AN/AAQ-37 Distributed Aperture System, or DAS. This consists of 6 high-resolution infrared cameras mounted around the aircraft. Camera 1, front, Camera 2, top, Camera 3, right, Camera 4, left, Camera 5, bottom, Camera 6, rear. They are positioned to provide a complete 360-degree spherical view of the surrounding airspace. The DAS constantly watches for threats in all directions. It can detect the heat signature of an incoming missile from hundreds of miles away, automatically alerting the pilot and cueing countermeasures. The true magic of the F-35A is not just the power of these individual sensors, but how it combines their data. This is called sensor fusion. The aircraft's central computer takes the information from the radar, EOTs, DAS, and data from offboard sources like other F-35S and AWACS aircraft. It then fuses all of this information into a single intuitive display for the pilot. On the large panoramic screen in the cockpit, an enemy aircraft is not just a radar blip. It is a single clear symbol, identified and tracked by multiple sensors. This eliminates the need for the pilot to mentally stitch together information from different systems, freeing them up to focus on making tactical decisions. The F-35A excels in all these areas. It is a machine built for the information age of warfare, where knowledge is the ultimate weapon. A digital arsenal, weapons, and internal carriage. The F-35A's lethality comes from its ability to carry a sophisticated mix of air-to-air and air-to-ground weapons. To maintain its stealth characteristics, the aircraft carries its primary loadout in 2 internal weapons bays located in the fuselage. For a typical air superiority mission, an F-35A might carry 2 AIM-120 AMRAAMs and 2 AIM-9X Sidewinders. This combination allows the pilot to engage targets from beyond visual range and also defend the aircraft in a close-in fight if necessary. For missions against ground targets, the internal bays can be configured to carry precision-guided bombs. A common loadout includes 2,000-pound GBU-31J DAMs. These are GPS-guided bombs that can strike fixed targets with incredible accuracy in any weather. The F-35A can also carry 500-pound GBU-12 Paveway 2 laser-guided bombs. The jet uses its own EOTs to guide these weapons to their targets. In situations where stealth is not the primary concern, the F-35A can carry a much larger weapons load externally. When these are used, the aircraft is operating in what is sometimes called beast mode. In this configuration, it can carry an additional 15,000 pounds of ordnance. The F-35A is also equipped with an internal 25mm GAU-22A 4-barrel Gatling gun, mounted inside the fuselage to maintain stealth. It carries 181 rounds and can be used for close-in air-to-air engagements or strafing ground targets. This internal carriage makes the F-35A a potent strike aircraft, capable of penetrating deep into enemy territory, destroying command centers and air defense sites. While this configuration sacrifices stealth, it dramatically increases the jet's firepower. It allows the F-35A to function as a highly effective bomb truck in environments where air defenses have been suppressed. The gun provides the pilot with a last-ditch weapon if missiles are expended, or if the rules of engagement require visual identification before firing. The integration of long-range missiles, precision bombs, and a cannon makes the F-35A a truly multi-role platform, capable of handling a wide spectrum of combat missions. From air superiority to ground attack, the F-35A's weapon systems provide unmatched versatility and lethality. Who flies the Lightning? Global partners and operators. The F-35 program is not just an American project, it is a massive international collaboration. The United Kingdom, Italy, the Netherlands, Australia, Canada, Denmark, Norway. They contributed funding and industrial expertise to the program. In return, their industries get to build parts for every F-35 produced, and their air forces get preferential access to the aircraft. This partnership model spreads the massive cost of developing a new fighter jet and ensures a degree of interoperability between allied air forces. Beyond the initial partners, the F-35A has become a popular choice for many other nations seeking to modernize their air forces: Israel, Japan, South Korea. The F-35A is designed to perform a wide range of missions, making it an attractive one-size-fits-all solution for many air forces. Its primary roles include offensive counter-air, which means hunting and destroying enemy aircraft, and suppression of enemy air defenses, or SEAD. The SEAD mission is one where the F-35A particularly excels. Its ability to sneak past enemy radar allows it to get close to and destroy the surface-to-air missile sites that pose the greatest threat to non-stealthy aircraft. Once the F-35As have cleared a path, older fourth-generation jets can operate more safely to strike other targets. The aircraft is also a capable platform for close air support and strategic attack. This versatility is a major selling point. It allows air forces to replace several different types of older, specialized aircraft with a single, highly capable platform. In the cockpit, training the modern fighter pilot. Flying an F-35A is a completely different experience from flying an older fighter jet. The cockpit is dominated by a single, large panoramic touchscreen display. Gone are the dozens of round dials, switches, and small screens. A pilot can customize this display to show the information they need for a particular phase of the mission. They can swipe, pinch, and zoom, just like on a tablet computer. One of the most futuristic pieces of equipment the F-35A pilot uses is the helmet. The F-35's helmet-mounted display system costs around $400,000. It is far more than just a helmet. It projects critical flight information like airspeed, altitude, and heading directly onto the pilot's visor. More impressively, the helmet is connected to the jet's distributed aperture system, or DAS. When a pilot looks down at their own feet, they don't see the floor of the cockpit. They see the ground below, as if the aircraft itself were transparent. Training to become an F-35A pilot is a long and demanding process. It begins with extensive academic work and time in a high-fidelity simulator. These simulators are incredibly realistic. They can replicate the F-35A's cockpit and flight characteristics with stunning accuracy. The simulator allows them to experience and learn from emergency procedures that would be too dangerous to practice in a real aircraft. They can also link multiple simulators together to practice formation flying and cooperative tactics with other pilots. A significant portion of a pilot's training now happens on the ground. Actually flying the jet feels surprisingly smooth and automated. The advanced flight control system makes the F-35A very easy to fly from a purely mechanical standpoint. One pilot described it as being less about stick and rudder skills and more about being a manager of information systems. The real challenge is not keeping the jet in the air, but effectively employing its vast array of sensors and weapons. The pilot's role has shifted from being a traditional aviator to being a tactician and a battlefield manager. They are the human element at the center of a powerful, data-driven war machine, making the critical decisions that lead to mission success. The generational leap: how the F-35A changes air combat. The F-35A represents a fundamental change in the way air combat is conducted. It marks the transition from the fourth generation of fighters to the fifth. Fourth-generation jets like the F-15, F-16, and Su-27 are defined by their high speed, maneuverability, and powerful radars. But modern air combat is rarely a one-on-one duel. The F-35A was designed to operate in a networked environment where its greatest strength is its ability to see everything without being seen. The key difference is situational awareness. A fourth-generation pilot has to build a mental picture of the battle space by interpreting information from their own radar, listening to radio calls, and looking out of the cockpit. An F-35. A pilot has this picture built for them by the aircraft's sensor fusion engine. They see a clear, unambiguous display of all friendly and enemy forces in the area. This allows the F-35A to act as a quarterback in the sky. A flight of 4 F-35s can share data seamlessly. One jet might detect a threat with its radar while another tracks it with its passive EOTS sensor, all without the enemy knowing they're being watched. This information dominance completely changes the tactical equation. An F-35A pilot can guide missiles fired from other older aircraft. For example, an F-35A could fly deep into enemy airspace, detect a target, and then send the targeting data to an F-A-18 Super Hornet flying dozens of miles behind it. The Super Hornet can then launch a long-range weapon at a target it cannot even see with its own sensors. The F-35A acts as the forward observer, enabling the entire force to be more lethal and survivable. It makes every other aircraft on its team better. This networking capability is a true generational leap. This new way of fighting renders many traditional tactics obsolete. The classic dogfight or visual range engagement is something the F-35A is designed to avoid entirely. Its stealth and long-range sensors allow it to achieve the first look, first shot, and first kill. By the time an older aircraft's radar warning receiver alerts its pilot to the presence of an F-35A's radar, a missile is likely already on its way. This forces adversaries to completely rethink their air combat doctrine. The F-35A changes the rules of the game, forcing a move from a contest of maneuverability to a contest of information. The future is now. The F-35A's lasting legacy. The F-35A is more than just a new fighter jet. It is a flying testament to the future of military aviation. The technologies pioneered and perfected in this aircraft will shape the design of combat planes for decades to come. The deep integration of stealth, sensor fusion, and networking. This is now the baseline for any future 5th or 6th generation fighter. The software that runs the F-35A is arguably as important as the hardware itself. The jet is an upgradable platform. Its capabilities can be enhanced over time through software updates, much like a smartphone. As new threats emerge, new software can be written to improve the performance of the radar, the electronic warfare systems, and the sensor fusion engine. This software-defined approach to aircraft design is a key legacy of the F-35 program. The F-35A's role as a network hub also points toward the future of air combat. The jet is designed to work with unmanned systems, or loyal wingmen. In the future, an F-35A pilot might command a small swarm of autonomous drones. These drones could fly ahead of the manned aircraft, to scout for threats, carry extra weapons, or conduct electronic jamming. The F-35A pilot would act as a mission commander, directing these unmanned assets from the relative safety of their cockpit. This concept of human-machine teaming is a central focus of future air power development, and the F-35A is the platform that is making it a reality. In conclusion, the F-35A Lightning II has fundamentally rewritten the rules of aerial warfare. It has shifted the focus from speed and maneuverability to information dominance and stealth. While the program has faced its share of criticism regarding cost and complexity, its core capabilities are undeniable. The aircraft provides its pilots with a level of situational awareness that was once the stuff of science fiction. The F-35A is not just the most advanced fighter in the skies today, it is a window into the very future of flight itself.